Okay, hello and welcome to the Virtual Jug. And joining me today on this session is the awesome Cedric Champeau. Cedric, how are you doing?
Hi, excellent, and hi to everyone.
Awesome. And normally in Nantes in France, but today you join us in, did you say Frankfurt?
Yes, yeah, this is my hotel room, and I'm currently just working with the Gradle team in Frankfurt for the week in just what we call a performance burst, so working on performance. So that's exactly aligned with what we're going to talk about today.
Awesome. So yeah, what are we going to talk about today? Are
So
we going all in with Gradle, huh?
Yes, I'm going to give a very short introduction of what is Gradle and what you can do with it, and more specifically talk about high performance builds, so how we can leverage Gradle to have much faster builds and releases in general.
Awesome. And how are you finding the take up of Gradle these days?
How do you find, sorry?
How do you find the adoption of Gradle, the take up of Gradle? What's the biggest problems people have, and why do
So
people go to Gradle?
I would say that today most people come from the Android ecosystem, but we have also more adoption coming from the native world those days. So people using Gradle to build C++ or all that native ecosystem applications, just because of the capabilities that we have that are just too hard to figure out with CMake or whatever. So yeah,
Mm-hmm.
basically two main adoption
Awesome.
channels.
Okay, awesome. So before we get started, then let me just tell the VJug people how they can interact and what they're going to be listening to today. So up now is extremely fast builds with Gradle, and as I mentioned, our speaker Cedric Champeau is here with us, and Cedric is on Twitter at Cedric Champeau on Twitter. So please do follow Cedric for plenty of tweets about not just Gradle but Groovy and many other things as well. The Virtual Jug is sponsored by Zero Turnaround, and media partner is Rebel Labs. So do check out some of the tools that that Zero Turnaround have, including JRebel and XRebel, and also a new performance tool that catches performance regressions in testing. That's actually a beta product right now, but you can check that out as well. And that's all from zeroturnaround.com. To interact with Cedric and the rest of the VJug, you can go on to IRC on pound virtual jug, and if you're viewing from virtualjug.com, you'll be able to see the IRC widget right next to the YouTube widget. So as you're watching, you can type some questions in, and you can add discussion to the rest of the group. Questions will most likely be taken at the end, or most likely be asked at the end, but you can ask questions all the way through, and many other people will put in their 2 cents, and we can have a great discussion. Please do share the group and session. We're well over 10,000 members now, and it would be great if we can increase that. So please do share on your social network of choice, or with your friends and families alike. If you have any feedback, please do always ping me at Virtual Jug or at SJ Maple, which is me directly. So please do tell me what you think of the session, tell me what sessions you want, and tell me what you think of the Virtual Jug. So that's that pretty much. This is actually the last session of 2016. So I'll put some new sessions up for 2017. We do have a lot of sessions already lined up for 2017. So you'll see them shortly. But for now, I'm going to pass straight over to Cedric. And Cedric's going to talk to you about how you can be lightning fast with Gradle.
All right, so let me share my screen now. Okay, so you should be able to see that. Okay.
I can, yep.
Right, so yeah, today I'm going to talk about Gradle, what is Gradle, what you can do with it, and in general, it's better just to start with a short demo of what you can do, so I'm going to do that. But before, yeah, I need to present a bit myself, so you talked about that. So I work for Gradle, so I'm currently employed by the company named Gradle Inc., which is behind the open source project of the same name. And I'm also actually a Groovy committer. So I've implemented some features in the language, like the static compiler recently, traits, multiple DSL capabilities. So in general, yeah, I'm pretty involved in the Groovy community, and Gradle uses Groovy So it was pretty natural for me to go to Gradle. And it doesn't mean that Gradle actually is written in Groovy, but it uses Groovy intensively. So the examples I'm going to show are actually Groovy scripts. So let's continue with that. So before talking more about performance in Gradle, I'm just going to do a simple application, so using Gradle. So Gradle is mostly what we call a build tool. So we know about Maven, we know about Ant, probably people doing Scala know about SBT. There are multiple tools like that. So Gradle is in that category. So it is a tool aimed at facilitating development of applications, so compilation of applications to deployment of applications. So in the what we call the modern era of continuous deployment, basically. So as a simple demo, what I'm going to do is just write a very short Java application. So I'm just going to create a source tree, source main Java. So if you're familiar with Maven, this is really exactly the same. So we're going to follow the conventions of Java. So I need class. So let's create something called hello.java, public class hello. Unfortunately, this is not Groovy, so I have to write a lot of code just to do some main arguments. Let's do this. So this is all the unnecessary code and boilerplate code that you have to write in Java just to print something. Classic things. Well, let's say hello plus args 0. Okay, so this is a simple Java class. And now we want to compile that. So I'm going to write what we call a Gradle script, which is named build.gradle. And what I'm going to do here is apply plugin Java. And by doing that, I am telling Gradle I'm building a Java application. So now I'm going to execute Gradle. Gradle say tasks. I'm going to run a daemon, start configuring everything. So the first run is going to be a bit slow, but I'm going to talk about that later. And we have all the list of tasks that you can have in a typical Java application. So just now, I'm just interested in building, so I'm just going to do Gradle build. It's going to compile my simple Java class. So I can see it's compiling Java, it's processing resources, but I don't have resources. It's going to build a jar. It's going to run the tests. I don't have any tests. That's not a problem. But if I do tree on the build, what I can see is that it compiled my hello class. It produced a jar, and that's all. So for a simple Java project, all I have to do is apply plugin Java. So this is really the simplest thing that you can do. And well, this is cool, but I want to execute that class. So actually it's more than just a Java project. It is a Java application. So what I'm going to do is just tell, okay, Gradle, this is not a simple Java project. This is also an application, and an application has a main class. So now I'm going to tell it main class name hello. If I run, it'll run. No, I will have a new task called run. It's going to compile everything and run. And oh, I have a bug in my build. Okay, the bug is really simple because if I look in my hello source main Java hello class, I can see that actually I'm using the first argument. So I need to tell Gradle that when I run my application, there are some arguments that I need to provide. So I need to edit my build again. And actually, I'm going to configure the run task. Say it has arguments. And one of the arguments is virtual jug. Now I can save my build file, run again. we go. So this is just an example of what you can do with Gradle. The idea is that everything that is simple should be simple to write, should be simple to read. But in the end, what you have is what we call a build script. And the script is not something that you consider as hacky. It is something more to be considered as a scenario in a movie or whatever. So a sequence of actions that you have to execute to produce some outputs. So in this case, I'm producing an application. So if I come back to my build tree, I have my demo jar. So inside that jar, Gradle automatically, by applying the application plugin, set the manifest exactly as it should be using the main class name, etc., etc. So simple things should be simple to do. And then, well, let's continue and talk about what we can do with Gradle. So Gradle is a build system that is not just meant to build Java applications. It is just meant to build any kind of software. So one of the biggest differences with all the build tools like CMake, like Maven, like SBT is that it is not dedicated to a single language. So you can build Java applications, you can build Groovy applications, Scala, web applications, Clojure, Kotlin, well, any kind of application. And what we will try to do is to provide plugins that know how those specific applications are modeled. So one of the reasons the Google team chose Gradle for Android is that the conventions that you can find in Android applications are very different from what you can find in a Java world. So Android typically has the notion of variants. So you can have, an application which is released on different devices. So you have different target platforms. You can have an application which has a free version, a paid version, a demo version, etc., etc. So the model of Android applications is very different from what you would have in a typical Java application. So Gradle will let you, as a build author, declare everything in a clean DSL and then let the build tool do the rest. So yeah, this is really the basic introduction to what you can do with Gradle. And now in that talk, I'm going to talk more specifically about why performance matters basically during those builds. Okay, so the quick agenda for this session is talking about what the Gradle Demon is, how we can profile builds, what is an incremental build, what we mean by incremental compilation, continuous builds, composite builds, and sometime later, the build cache. So if you're already a user of Gradle and that you've been using Gradle since 1.0 maybe or 2.0, you maybe know that there was something hidden in Gradle that was called the Gradle Demon. And the Gradle Demon is something really simple. It is a process that remains in memory even after you have done a build, and that is ready to listen to build requests. So it is a hot daemon that will execute the builds. And that wasn't enabled by default in the previous versions of Gradle. Since Gradle 3.0, we enabled that by default. So I'm going to show you why it matters, actually. So the Gradle daemon is, a long-lived process. And what it does is listening for build requests. The benefit is that you will get faster startup for your builds and faster execution in the end. So I'm going to explain why. But what you've seen in my first example is that I had something without any daemon running. So my first build was slow. And that is because we had to set up all the build environment and prepare the daemon in the background. So what it means in practice. So this is, let me refresh that page. It's going to be better. So in the left, what you have is a typical Gradle project on Gradle 2.0 without the daemon, and on the right is the same project with the daemon. So I need to hide that. Yeah. So this is a real project. This is Mockito, which is a real project built with Gradle. And what you can see is the effect of what we call a cold daemon. So it's a daemon which is there, but that hasn't run many builds. So what we can see is that already just with a cold daemon, we take around 10 seconds to build the project, whereas without that daemon, it takes around 16 seconds. So we already saved 6 seconds in building the project, but we can do better than that. The good thing is that Gradle is something that is built on the JVM, and we know as Java engineers that the JVM is probably one of the best runtimes in terms of optimizing what you find at runtime. So we have the JIT, and the JIT is what? The JIT is something that is really smart and it's capable of compiling the Java bytecode into native bytecode at runtime, depending on what is actually happening during runtime. So the more you're going to execute a program, a Java program, the faster it's going to be, just because the JVM is going to understand that this pass is probably only executed with that type and optimize everything. So for free, using the daemon, you're going to optimize that. And what we will have is on the left, that project with no daemon, and on the right, the daemon, but hot. And in the end, we fall to 5 seconds only. So if you didn't have the daemon before and did not activate it, it was 16 seconds. And now it is 5 seconds. And it's going to improve as you run more builds. So yeah, there is a strong interest in keeping the daemon there. So Gradle Trio does that by default. And this is much better for the users. And maybe you wonder why it wasn't the case before, why it wasn't enabled by default before. And one of the reasons was that the daemon was pretty unstable under Windows, and that's fixed. So if you use Windows, or if you're forced to use Windows, unfortunately, yeah, you had a problem basically because the daemon kept some files open, or you can delete some files. Well, the typical things that would happen on Windows if you don't close some resources, it happened with the daemon, and now it is much more stable. So you get that for free, independently of your operating system. So Windows, Linux, whatever, macOS. Yeah. Okay, so now what we want to do is improve the performance of our build, because we consider at Gradle that performance is really important in terms of productivity. So if you think about the number of times that you're going to run a build in a day, it is huge. And especially if you think of the IDE running the build system in the background, which it should be in the end, because the build system knows much more about the model than just the IDE, it's going to be super important to optimize that process. So we want to provide some tools for that to be easy. And historically, what we had was just one option that you add to your Gradle build, which is called -- profile. And that -- profile will generate a report in a simple output directory that will tell you how long the build took, how long the configuration took, and how long basically the execution of each task took. So this is interesting, but it is super limited in terms of insight of what is really happening during the build. So instead, now, when you talk about Gradle, we need to think about two different things. So Gradle, the command line tool that I've been showing so far, and the second aspect is the cloud services, which is also free. And that cloud service has a feature called the build scans, which let you have much more insight about what is happening inside the build, but that independently of where it is running. So it can be on your local file system, local laptop, it can be on CI server, it can be anywhere in the world. All the informations about all the builds that are run are collected and pushed to cloud. And then we generate a URL, you click on that URL and you have insights about your build. So I'm going to paste the link to the slides at the end of this session, but yeah, you can find some demo links on the Gradle website itself. There are 3 of them here. One is a real project, real life project, which is Groovy. Second one, I'm just going to open that one. I'm going to see a build scan in action. So maybe I can try to increase the font for this. Yeah. So, okay. So this is a build scan, and a build scan is interesting because it gives you much more insight about what is happening. So typically we're interested in performance, so we can click on the performance link and explore performance. So it will tell you to build that project, it took 11 seconds, but yeah, around 1 second just for startup, evaluating the builds, configuring the project 3 seconds, which was a bit slow. And then task execution. So you can click on the various sections and get insight about what is really happening during the builds. You can see actually how many builds were executed in the daemon, for how long it was there, etc., etc. And then you have one section which is called settings and suggestions that will tell you, okay, maybe you should enable parallel execution. And if you don't know what parallel execution is in Gradle, maybe you want to learn about that. So it's going to give you some hints about your build. Yeah, let me open the second example, which was the Groovy one, to give you an example of what can go wrong in a Gradle build. So I can explore the performance link again, go in settings and suggestions, and what it's going to show me is exactly that. So it is telling me, oh, you have dependencies which are resolved during project configuration, and that is not right. In terms of yeah, what is happening during the build, it means that you're doing too much during the initial startup of the build. So dependency resolution should only be triggered if you execute a task, not more. So that was a real problem found in the Groovy build that we could fix using these build scans, because it gives you an insight of what is happening. So if I go to the last example, I can just basically give you some ideas of what you can do with the build scan is that you have those custom values things. So this is typically things that would be very specific to your project. So you can add some informations to the build scan. So you can, yeah, you can tell this is how much disk that project was using and push that, or you can have a link to the sources. So if I click that, I can know exactly what was the commit associated to this. I can see that it was a local build using a master branch. Yeah, see all the output. In the task section, I can see exactly which tasks were executed. If there were failing tests, I would see the failing test. And the idea behind that, I don't have to show much more than that, but the idea is that if you have a failing build, and that is local, what you typically do is to send a stack trace to a colleague, and you send the stack trace and you say, do you know what the problem is? And usually the answer is, oh yeah, but can you just paste the complete stack trace, please? Oh, I don't have it. Oh, why? Just because it was hidden in the build. So you couldn't have the stack trace, and you cannot share it, and you cannot solve the problem. With the build scan, you just have everything collected from your local builds to the CI builds, everything in a single place. So you can share a build scan instead of sharing the just the stack trace. And what I've done recently is, yeah, another example is that as a custom value, you can paste the diff between your local build and what is in the Git repository. So when the build is going to stop, it just submits a scan, and that scan contains a link to the gist, and the gist contains the diff, git diff. So you can just provide your colleagues with exactly the same environment as the one you're running without having to push anything. So that's the kind of things that are really, really interesting to do some troubleshooting of builds in general. And it can come from dependency management. It can come from, I don't know, a Java version which is different, the operating system which is different. So yeah, typically solving the it works on my machine and it doesn't work on yours. So yeah, you have two features basically in Gradle today: Gradle, the command line tool, and Gradle, the build scans. And yeah, how we do that. So the only thing that you need to do is actually apply a plugin, which is called the Gradle build scan plugin. And you have to agree on the license for one very specific reason. This is public. So if you publish a build scan, it is published on our public instance. If you want a private version, it is possible. We can talk about that, but that's basically something that we're selling. So you wouldn't push basically on a public server, public instance. And then once you said, okay, I agree with the terms of service, you run the build with that argument, Gradle-d scan. The build executes, and in the end, it produces that link. So you click on the link, and there you go. You have your build scan that you can share with anybody. So if you go to, typically to the Gradle build, we execute that for all the CI builds. So there is also a link to the Travis build. So from the build scan, you can take everybody to either the Travis build or the commits on GitHub, etc., etc. So it's pretty useful. Right. So enough about build scans because we have many things to discuss today. So now we're going to talk about how in practice you can improve your productivity with Gradle. And one of the first things that you can do is to do incremental builds. And what we really want to promote in Gradle is the fact that Gradle is meant for incremental builds. It means that if you're using Maven today, a typical problem it is a reaction to a broken tool, but basically people do clean, install every time. So clean, compile, clean, test, clean something, clean. Just because if you don't do clean, well, it's broken. You can have leftover classes. It is a total nightmare, especially if you have multiple subprojects. So clean is a total waste of time. You don't need to do clean. If the tool is smart enough to know exactly what the inputs and outputs of each tasks are, then you don't need to do clean anymore. All you have to do is just execute the task again, and the build tool is going to realize, oh, this source set has a new file, or this class has changed, so I need to recompile and do nothing more than that. So yeah, you change from clean everything, build from scratch every time to how can I enhance my build to explain to Gradle what it is doing. So what does it mean in practice? So the example I'm going to take is, imagine that you want to build what we call a shaded jar. So a shaded jar is typically, sometimes it's called as a fat jar, but the difference with a fat jar is that you want to repackage dependencies into different packages. So you have, you want to embed, I don't know, the ASM library, and you don't want that to be visible as a transitive dependencies to your consumers, so you want just to shade that into your own jar. So repackage the ASM library into your own jar. So it's a typical shaded jar. So you, as the developer of that shaded jar plugin, exactly what is necessary to produce a shaded jar. So we know that there is an input, which is the class path, so your classes plus the dependencies. And we also need a mapping, which is, okay, I'm going to remap everything which is in org.apache.something into shaded.org.apache. So ClassPath and mapping are inputs to your task. And you know, as a developer of that task, that jar file is actually the output. So if you, as a developer of a plugin for Gradle, you know that jar is an output, that ClassPath is an input, and that mapping is an input, you can tell the tool. And this is going to be super important to tell the tool, because it means that if so it's an output, if it is missing, I need to execute the task. If the class path is the same, or if the mapping is the same, so both inputs are the same, you don't need to re-execute the task if the jar is present. But if you change the mapping, if you change the class path, you need to re-execute. So this is something that you can tell, and I'm going to explain how you can tell it to the build tool. So this is typically how you would declare those inputs. And here I am assuming that you're writing your Gradle plugin in Java. And what we're going to do is just add an annotation, input files on the ClassPath property. Method called getClassPath, which is going to return on this class path, and it is annotated with @input files. And file collection is actually an internal type in Gradle. Well, not an internal type, a public type in Gradle. So file collection is something that can do dependency resolution, that can be just a set of files, whatever. So it's an abstraction of a different set of files. And I can do the same for the mapping. So the mapping is just a map of string to string. So let's declare that as an input. And that's all I need to do. I just declared the inputs of my task to Gradle. And now it's going to benefit from that incremental build execution. But I also need to declare the output. So similarly, we have an annotation called output file that generates a single file. So the jar file is an output. And that's all. So I have a task, I declare inputs, I declare outputs, and now every time I'm going to run that task, Gradle is going to check, have the input changed? Yes, no. If it doesn't change, or if the output is missing, then I need to regenerate. So it's super easy. And if you don't do that, you just lose your time. Just because Gradle will not know what is the input, it will not know what is the output, so it will have to execute everything every time. And that is exactly what is happening with typical build files, typical build systems like Ant or Maven. So they will never know what your plugin is doing, basically, unless you implement the incrementalness yourself. And this is not something trivial to do. So better use a tool that is meant for it. Okay, so that's what we call incremental builds. But if you're into the Java world, and most likely if you use Eclipse, you probably know about incremental compilation. And that is another level of incrementalness. So the idea is that you have a set of source files that you want to compile, but you only change one source file. And you need to recompile only that source files and actually all the different source files that depend on that one. So this is typically something that the Java compiler doesn't, the Eclipse compiler does, and there's a good reason for that, but I don't have time to explain why. But it means basically that incremental compilation is dependent on the language. It depends on the fact that you have Java. It depends on the fact that you're using Groovy. It depends on the fact that you're using Scala or whatever. So today, the only incremental compiler that we have in Gradle is for Java. So it is aware of Java sources, and it's going to analyze the generated bytecode and analyze the dependencies and only recompile what is strictly necessary if you change something. But to do that, you have to enable the option. So when you compile Java, you have options, and one of those options is enabling incremental compilation. So it's not enabled by default. It's probably going to be enabled by default pretty soon because it's been there for a while and we don't have, well, we didn't have any bug reports so far. So it means that it's probably pretty stable. And if you do that, yeah, you just cut off a lot of build time if you just change a single source file or whatever. And that's actually pretty common to just change a small set of source files. But yeah, only limited Java today. Then another way you can save time during your build and during your development mode is to use a new feature which I think arrived in Gradle 2.4, if I remember well, which is the continuous build mode. And this one is just activated using the -t flag. And what it does is monitoring for changes in the background. So we use something. So this slide deck is typically written using ASCII Doctor, Gradle, and Reveal.js as a backend. And when I'm writing my slides, typically what I'm doing is that I have that source file, which is there, my ASCII Doctor slides, and I just do a modification. So let's see if I'm going to ASCII Doctor. I'm going to find the slide I am on right now. Where is it? Yeah, the continuous mode. I'm going to add some blah, 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 save the file. And when I come back to my slide, it should refresh. Yeah, and it's live. So actually, it just changed because I hit Control Save, and I had here my Gradle build running in the background with -t. So it realized that I changed my source file and recompiled everything in the background. So I didn't have to do anything, and it's just refreshing. So it is super, super nice if you are doing exactly only the same task again and again. So you can do that with test, you can do that with, I don't know, jar, compile, etc., depending on what you want to do. But the idea is that you have a task that you always execute and you don't want to run the build tool every time. So let it monitor the changes and do the build. And you can do that because Gradle knows the inputs. So if you change something, it will know that, okay, I only have to re-execute that ASCII Doctor task and nothing more. So it's super handy, but it is limited to a single task or a set of tasks that you execute often, I would say. So yeah, pretty nice, but limited usage. What is really going to change our lives is probably more the composite build features that we recently introduced in Gradle. So yeah, for listeners, there are probably two categories of listeners today. The ones who have a big repo with a lot of different sub-projects, so what we call the mono repo, and you have everything in a single repository, lots of modules, you import that into your IDE, and it just blows up because it doesn't have enough memory. Or you have the second type of users, which are, oh, this is really not nice. I'm going to create a different repository for each of my modules, and I'm going to publish that and consume that, etc., etc. And the problem that happens typically in that use case is that if you have a problem in one module, you have to republish each time you want to fix a bug. So that's, yeah, that's a bit problematic too. So we have two modes, mono repo, which is very practical, very handy for development because you have everything at hand, and maybe you publish everything as a single entity. And the second approach, which is, okay, everything is splitted, but it is really annoying if you find a bug in a different module and you want to fix that. So the idea of composite builds, it's to bring those two worlds together, that so that you can specify different independent Gradle builds and then compose them as if they were a single one. So it is much better to explain that using a live demo. So I'm going to do a demo of what really composite builds are for Gradle.
Just a quick question around
Yes.
the continuous builds.
Yeah.
Question from Maldiva and IAA on IRC about how that works with IDEA if you have to, when you just save a file, or if you're doing something that won't compile at all. How would that work with continuous
So
builds?
it is independent from the IDE. So you just run something in the background, and if the IDE does compile by itself, which is generally the case, you're going to have to compile in your IDE also. So it is really two different processes. It is more intended if you're basically more into command line, or that what you do is not integrated into the IDE. So
Okay.
typically Asciidoctor is not integrated, so it doesn't know how to produce the build output, so how to produce the slides, sorry.
Okay.
Right. Okay, so let's come back to the composite builds, which is, I think, one of the best features that you will find in Gradle today. So what I have here is what I call a mono-repo application. So I'm going to show you typically what is a multi-project application in Gradle. No, I want to show the build.gradle of that application. So it's a Java application. I'm using IntelliJ for editing that, but it has two dependencies, one on number utils and the second one on string utils. And the rest, we don't care. But basically, it is an application, and that application has sources, main Java, main.java, and what it does is adding two numbers. So that's really complicated, numbers that add. And of course, the answer should be 42, as usual. So I'm going to run that. So GL is just an alias for Gradle that I'm using. So instead of having to do Gradle, just GL. So if I run that application, I'm going to run that. It's going to start the daemon because this is the first time I'm using it. And I can already see it's using the composite build, but it's not really a problem today. The problem is that I have a bug. It says 43, but it should really be 42. So, okay, is there. I'm going to go full screen mode. Readable now. So I have numbers that add. And if I click that, oh, I have found the bug. Actually, the bug is that there's a +1 here. So I want to try to edit that, but I cannot remove that. And why? Because it's a binary dependency. This is number utils, and number utils is actually something that I published. So, okay. So actually what I need to do typically is to change, I need to check on the number utils library. I need to fix it, and then I need to publish it into my local repository, then change the dependency to a snapshot version. Then maybe I can continue my work. So it is super, super expensive. And that's not what we want to do. Instead, we want to replace that binary dependency with something from source. So that's exactly what I'm going to do. And I'm going to do that by putting something into my modules directly. So I have my string utils dependency here, but I'm going to do something else. I'm going to move my number utils project into modules. So what I'm doing here is not magic. It is just that number utils is totally separate. It is a different repository, a different Gradle build, and the only thing I've done is just moving it to modules just for Gradle to recognize that. So I'm going to run the build again. I'm going to find 43, but now the big difference is that I can regenerate my IDE project. It's going to refresh there. And now in my modules, I have number utils, right? And I can go into my main, go to numbers.add, and then I should be able to edit that. Yes, I can. And run again. Oops, not wrong window. Run. And now I have 42. So what really happened here is that Gradle substituted a binary dependency with a source dependency. So my dependency here, dependency that I have is on number utils, a published version. And using the composite builds feature of Gradle, I just substituted that dependency with a source dependency. And it is super powerful because it's also working for transitive dependencies. So what I can show you is that my string utils project, which is here, has a dependency on Apache Commons, which is typically a project written using Maven, published using Maven. And I can also modify and substitute that transitive dependency with a source dependency. And here I can do it just by moving from my commons line project here to the modules directory. Oops. Run the build again. To configure, and maybe you haven't seen the difference before, but now I'm building number utils, I'm building commons lang, and I'm building string utils. And if I move everything out from modules to attic, which is something outside of that directory, run again. Now it's 43, but why 43? Because it's using the binary dependencies instead of the source dependencies. So it is all dependency substitution. And at this point, you probably wonder, wow, how does it work? And actually, there's no magic in that. You have to declare that. So it is very flexible how you declare that. And the way it's done here is that I'm using the settings.gradle file. And in the settings.gradle file, I have a small loop that says, look at all the files which are in the modules directory. And this is actually an external build. This is actually something that I'm going to include as if it was a local build. So it is totally dynamic. Anything I'm putting into that module directory is going to be a substitution in the dependency graph. So every time Gradle is going to find a matching group ID, artifact ID, whatever the version, it's going to replace it with the source version if it is available. And that's all you need. So that's one way to do it. There's also a way to do it from command line. So you would do something like Gradle -- include build, and then it will substitute the binary dependency with whatever you set there. So a different build. But what is really important to understand is that this is substituting a binary dependency with something from source. So you can totally imagine that you have that giant repository that you can now split into multiple repos and compose. And typically what happens is that, at least in large-scale enterprise builds, you as a developer only work on a small sub-project, or maybe 2 or 3 sub-projects of that gigantic project. So you can consume binary dependencies for everything that you don't care. So never pay the price of building that from source. Place the binary dependencies that you work on with source dependencies and have only those in the IDE. So everything would be binary except what you are specifically working on. So I don't have much time to talk about all the good things that you can do with the composite builds, but we have a couple of blog posts about that. We also have a pretty extensive documentation, so it's really super powerful. And I really, really invite you to look at that, because this is going to change the way you develop applications, at least in the Java world today. So super important. Sorry. So this is everything that I showed you so far is something that you have in Gradle 3.2.1, which is the latest release of Gradle today. But we're not stopping there, and there are actually features that are hidden in Gradle, or features that are in development today, which are really awesome and probably going to change everything in the future. So what's next? And one of the features that we're really excited about is what we call compile avoidance. And I'm going to explain that very simply by a simple example. This is a typical code that you find in any project out there. You have a getNames method that takes a set, it shouldn't be foo, it should be person, a set of persons, and you return just a set of strings, which is the list, of names of the different persons. And what's wrong with that? Nothing is wrong. For that to compile, what you need to do today, and with Gradle, it is exactly the same with Maven. You define the compile dependencies. So you say, okay, the person class comes from the subproject model. And actually, I was using Guava. So Guava is a dependency. So I have compiled Guava. So what's wrong with that? Well, what's wrong is that person is something that is exported. And what we mean by exported is that this is something that appears in your public API. So it should be person there, but the person class is exposed in your API. So if someone consumes that method, it has to know about the person class. But everything inside is purely internal details. Guava is an internal implementation dependency. You could decide to change it tomorrow. It would not break the way people consume your application. So the problem with the way we do it today, by defining the two dependencies, the external dependencies and the API dependencies and the internal dependencies in a single configuration named compile, is that we leak Guava into the consumer's class path when you compile them. So how can we fix that? What you're going to do tomorrow with Gradle, and that's going to happen pretty soon because we plan to ship that in Gradle for all in January, is that you would have two different configurations. One API, where you define the dependencies that are exposed in your project API. So the person class is exposed. So consumers of my library are going to transitively get that subproject model as a dependency on their class path. But Guava is a purely internal implementation detail. So when someone compiles against this project, it doesn't have to have Guava on the class path. And that's a typical huge problem, because if I decide to change from Guava 18 to Guava 19, then typically with a single class path, every downstream dependency is going to have to recompile because the class path changed. And worse than that, you actually leaked an internal dependency into the dependencies of your downstream consumers. So this is really the worst thing to do, because you're going to recompile the world if you change an internal dependency. So just doing that API implementation, you make that much cleaner. And actually, you have no class path leakage anymore. And you get for free what we call compile avoidance, which is you change something internal and then it doesn't have to recompile. What we're going to do now, actually it's also available in what we call the software model, is that you're going to be able to specify your public API in terms of exported packages. And this is what you're going to see with Jigsaw tomorrow. And in Gradle, you're going to be able to say, okay, Comfoo is exported, so consumers will only see Comfoo and not Comfoo internal. So when you're going to compile, it's going to complain that the internal classes are not allowed if you can try to use that. And it would work for Java 7, Java 8, not specifically for Jigsaw. Right, so this is something that's going to be really interesting for avoiding those compilation chains where you change, something, some library which is really the core, and then you have to recompile everything down just because something changed at the top. And yeah, the last thing I really wanted to talk about in that we call the build cache. And the build cache idea is that even if you do a clean, even if you do a checkout in different directory on a single machine, even if you're using a local clone and that a colleague just built something on a different machine, or maybe it was on the CI server, you don't have to build yourself if someone else did it, and maybe someone else is you previously. So share binaries between different machines, between a single machine. Yeah, so typically you have two different local directories with the same project because you don't want to mix the branches. If you have built something on one, you just want to share the same build results from the second branch if it's possible to do it. So that's what we call the build cache, and it's working locally, it's working on a network, etc., etc. And the idea is to have something which is backend agnostic. So typically we have a prototype that works with HTTP cache, but you can do some Hazelcast cache or whatever cache technology you want to use. And yeah, so the typical use cases for that are, you do a checkout, or maybe if you use Git, you're used to do bisecting. So it's going to change the commits for each iteration of the bisecting, and you have to recompile everything. And often 99% of the project is exactly the same, but still you have to do clean something because otherwise it would leave some sub-projects, outputs, whatever. And yeah, it takes a lot of time. Or maybe you're just switching branches, which is exactly the same case. So you switch a branch and you don't want to recompile everything if 99% of the branch contents is exactly the same. And just for the joke, yeah, the idea is you would just make the world a better place by doing that, because you won't recompile everything every time. So yeah, if I have 1 minute, I'm just going to show you that in action, and I can probably do that using that project. So if I do Gradle cleanal on that multi-repo project, maybe I should move all my sub-projects from attic to modules. Do cleanal again. So if I do cleanal run, what I'm going to see is that it's going to recompile everything. So it takes some time. Yeah, 4 seconds for that project, which is really simple, but clean takes some time. And now I'm going to enable the cache. Clean run. So the first time it's going to do all the work. And the second time I'm running it much faster, and only 1/5 second, just because it reused everything. And you can see it because it says from cache, etc., etc. So this is going to be available pretty soon in Gradle for all. All right. Just last note before I take some questions. There's a lot of things to say about performance in Gradle, so we take that very seriously. You can go on our GitHub repo, and we have a performance guide with hints what you can use, configure on demand, parallel mode, etc., etc. So different use cases, Android, not Android. So yeah, and what we do is that we have performance test suite running every commit, and each time we have a regression, basically we're not allowed to release without fixing that regression. So it's going to be faster and faster. Yeah, that's all I wanted to say today. So up for questions.
Awesome. So, getting some questions in right now. Actually, the first question, the first question I did ask, I think it lost a lot of context. I don't think I asked it correctly, but I'll try and repeat that. So we're talking about with continuous builds, whereby every time you save a file, something happens, a build happens.
Yeah.
With IntelliJ IDEA, every time you hit a key, a save occurs in the background. So what would happen in that instance?
So if you do a save in IntelliJ and that you have a Gradle build running in continuous mode, it's going to take the changes in any case. So it's really totally independent from the IDE. So the confusion is probably that even with IntelliJ, if you talk about typically Android Studio is using Gradle in the background, and when you compile in Android Studio, it's using Gradle in background to compile. This is not the case if you use IntelliJ and Java, so you can import the project in IntelliJ, but if you run compile, it's going to use IntelliJ's compile. So yeah, the behavior depends on your project. If you're using Java, if you're using Android, etc., etc. So really, just depends on the kind of projects you're working on.
Okay. Question from Chachali. First question, is there a plugin for Docker image creation?
Yes, so it's not supported by Gradle itself, but I think we have a couple of plugins dedicated to Docker. Yeah, so creating images, pushing. Yeah, I think there is something to push to the Docker Hub too. So yeah.
Okay. And the second question, do you think Gradle can replace Maven in a Java EE perspective?
Of course.
Is there anything,
of course we do.
Is there anything specific in Java EE, or is it just...
There's nothing really specific, but I think that once people realize the benefits of having a tool that understands the different models, so typically, yeah, building a Java application is different from building a Java library, it's different from building a web app, etc., etc. You can model your application much cleaner, avoid leaking class paths, producing different variants, etc., etc. So there are tons of benefits of having a much cleaner model. So yeah, usually people using Maven say, okay, it works for me, but they just don't realize how broken the model is. So,
okay.
Yeah.
Question from AAA, is Commons Lang Gradle or Maven?
It is Maven. So it's a Maven dependency in what I did. So yeah, I can probably show that. Yeah, I'm in the right repo. So in my modules, Commons Lang, what I have is exactly a checked out Commons Lang repo, and I can just do modules Commons Lang remove. So I'm not moving it to the attic. What I have here is where is it? Clone shell script, and what it does is git clone for Commons Lang, and actually this is a Maven project. So what we do after the clone is that we call Gradle project here, modules Commons Lang, and please init. And init is going to do what? It's going to convert the pom.xml file into a Gradle build file. So let's do that live. It's cloning. Done. And now it's converting the POM file into that module Commons Lang. So I still have the POM and that XML, but now I have a build.gradle file that was converted from the POM file. And it's using the snapshot version, but we don't care. We don't care about the version number. It's just going to replace the binary dependency by this one.
Okay. Question from MK Bit. The rule-based model configuration was talked a lot in the patch notes for the 2x releases. It seemed like it was going to be the new configuration model in 3, but it's not. I heard you mention something about it earlier, but what is going on with the rules model development?
So it is totally on hold, and it's probably not going to evolve. Just So there are two cases. The first one is the native ecosystem and the play ecosystems, which are totally built on top of that software model. But for the Java software model, we're probably not going to do anything more, just because we realized it was too high a cost for people to migrate to that, because it's really different the way you model your application. So typically all the plugins that work in the Java current model would not work with the software model, so you have to rewrite everything. So it's very high cost. So we decided, okay, let's just backport all the new features that we had only in the software model back to the current model, and make that possible for people to benefit from compile avoidance, multiple variants, platform aware, dependency management, etc., directly into the current model.
Okay. Question from Zorz Reichev. Any tips for improving build for Android or some blog posts?
Yeah, so there are several tips. So the performance guide that I linked has some ideas. There are also some good blog posts about improving the way you do it in Android Studio. In any case, we're just improving the performance a lot for Gradle 4.0, which is going to be released pretty soon, and hopefully it's going to change some things in the Android world too. So yeah.
Awesome. I also mentioned actually a couple on Rebel Labs. There's using build cache in Android Studio, which makes Gradle builds faster, and also Gerbil for Android actually has an incremental compiler as well for Android builds. So
yes. So the idea is that the Android build cache is different from the build cache that I mentioned in this presentation, but in the end, I guess it's going to merge at some point. So they're going to use the same. I don't know, but yeah, probably in the future.
Okay.
So it will not be limited to dexing typically in the Android world. It's going to be for anything that you would benefit from the cache.
Okay. And a question from Code Generator. Cedric mentioned that clean is not worth it, but is there one case where I'm still but there is one case where I'm still using clean when I run with --debug--jvm to debug with IDEA. The debugger doesn't catch on subsequent runs. Is there a better way?
I don't see why, but yeah, there are probably a couple of good use cases for clean. One, well, the obvious one is when you want to do release and make sure that you have nothing in your local repo that isn't, on the remote, whatever. But yeah, you could check that with the build scans in any case. For debugging, I'm not sure. Yeah, I don't have the answer for that.
And one final question, actually, because we're running over slightly. Ziga is asking, which compiler does Gradle use, Javac or something else?
Yeah, it's using Javac. Yeah. So I think there is also a plugin to use the Eclipse compiler, but we don't use it by default.
Okay, awesome.
Actually, in the task, you can set whatever Java executable you want to use. So if you want to use a different compiler, you can.
Okay, awesome. So I think that's pretty much all we have time for. So thank you everyone for attending. Big thank you to Cedric for not just your session actually, but for closing out the year for the Virtual Jug in 2016. Sorry. It's actually been a massive year for us, actually jumping up to well over 10,000 members and VJug 24, and it's just been amazing. So thank you everyone for attending that. Big thank you to Cedric for a great presentation, actually. And,
thank you for listening, and just Merry Christmas to everyone.
Absolutely, Merry Christmas and Happy Holidays to everyone to the Virtual Jug. I'll upload some. I'll add some more meetups on the meetup site probably before Christmas. So do check them out for 2017. And stay safe, everyone, over the holidays, and see you in the new year.
Yeah, goodbye.
Thank you. Bye.